All right, we're starting the Triangle Inequality, which is lesson 6.6 and is on page 15 in your notes. So we are going to be talking about the special relationship that must exist among lengths of triangle sides. And this is really helpful, especially when we start talking about the law of sines and law of cosines, which is really helpful in advanced geometry. So this one may seem really basic, but it's a good basic rule that's going to be helpful later. Okay, so here's the rule. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side, which really makes sense because if you start thinking about it, if you've got two sides, if you've got, I don't know, this side right here and this side right here, and this one's 2 inches and this one's 5 inches. If I'm going to try and get this back to here, it can't be also 2 inches because 2 inches would look like the same, right? It would be also there, 2 inches. 2 inches and 2 inches is only 4, and 4 inches would never reach, right? So the sum of the lengths of any two sides must be greater than the length of the third side. So this one and this one added together must be bigger than that one. So this one has to be greater than 3, right? So it has to be 3.1, 3.2, or it has to be whatever. All right. So let's look at that. The sum of any two sides must be greater than the third. So is it possible? So we're going to go ahead and add 9 plus 12 equals 21. They're greater than 18. Yep, that works. So that's bigger than 18, so we can make a triangle with that. That works for me. But 3 plus 5 equals 8. And that is not 8 greater than 8. That is not true. 8 is equal to 8, but 8 is not greater than 8. So in this one, 21 was greater than 18, so that was good. So, bummer. And look at this. They actually tried every single inequality that they could do with that. They went through every single possible one they could do. They added these together and made sure it was greater than this one. Then they added these together and made sure it was bigger than 9. And then they added these together and made sure it was bigger than this one. Okay? I just went ahead and picked the two smallest and made sure it was bigger than the biggest one, because that's what made sense in my brain. The two smallest have to be bigger than the biggest one. But there we go. And that's what I was going. How can you eliminate it by looking at only one inequality? Add the two smallest sides greater than the largest. Is it greater than the largest? And that's what they're doing here. 3 plus 5 is not greater than 8. Okay, so now you're going to check this one. Go ahead and pause me. Okay. Hopefully you got that the first was yes. 2 plus 5 is 7, which is bigger than 6. And the B is no, because 3 plus 4 is 7. 7 is not greater than 8. So that's a bummer. Now, the second one is, the second situation here is finding possible side lengths. So a delivery company uses drones to make speedy deliveries around the city. A drone leaves the home office and flies 8 miles east to its first delivery, and then 4 more miles southwest to a second delivery. What is the least possible whole number distance the drone will fly to return to the home office? So it leaves home office and flies 8 miles. So here's home. It goes east. So this way, 8 miles. And then 4 more miles southwest. So 4. What is the least possible whole number distance the drone will fly to return to the home office? Okay. So the question is, what is this number? If we were to go ahead and finish this, what is that value? X. And we're going to have to think that out. And is it going to be X plus 4 greater than 8? Or is it 4 plus 8 greater than X? Or there's one other option. It's 8 plus X greater than 4. I think we know that it should probably be one of these two, because 8 and 4, I mean, that doesn't really make as much sense here. And I think I lean towards this one. There we go. Let's go down and see what they do. They went ahead and made all of them, and they solved all of them right there. So 4 plus 8, and they solve that down, 12 greater than X. So X must be less than 12. So if we were to rewrite that out the other way, X less than 12, because rearranging that. This one, 4 plus X, so they subtract the 4, and we get X greater than 4. Or subtract the 8, and you get X greater than negative 4. Again, not going to be that one. The least whole number value between 4 and 12 is 5. So the original question is, what is the greatest possible whole number measure for, what is the least possible? There it is. What is the least possible whole number distance? Least possible whole number distance. So between these, X is less than 12 and X is greater than 4. And actually, we would write that typically as a compound. So X is greater than 4 and less than 12. Or if it was on a number line, 4 and 12, and it would go between there. And we would highlight that between there. Highlight. There we go. And the first number between there would then be 5. There we go. 5. That's our number. The least number would be 5, the least whole number. So it would have to fly at least 5 miles to the home office after the 2 deliveries. I hope that kind of makes sense what we're looking at in here. We're looking for solutions. It has to be greater than 4, has to be less than 12, and we're looking for the next whole number. All right, so go ahead and solve this. Install a smart thermostat. Kelvin is cutting a triangular hole in the wall. He marks side lengths of 2 1/8 inches and 2 3/16 inches. And solve these assumptions. Go ahead and pause me and solve part A and part B. All right, so for part A, did you find C, that he measured the side lengths accurately? and that B, the range is between 1/16 of an inch and 4 5/16.